Hey guys, so welcome again to my YouTube channel. So today we will be talking about mesh analysis when a current source is present in a mesh. So let us look at what is a mesh first. We'll also talk about the supermesh. So we all know solving a KVL equation, we use mesh analysis or KVL. KVL is a law and we use mesh analysis. This is a circuit. This is a circuit, simple circuit of resistance R and potential difference V. So some current is flowing I. So what we use is the potential across a same point is zero. KVL summation of all the voltage drop across a point in the mesh is equal to zero. So what we use is IR. Okay, IR minus, we are coming from this side to that side, you can check my previous videos, minus V is equal to 0 or V equal to IR. So this is what we call mesh analysis. We sum of all the voltage drops across a mesh which is equal to 0. Now suppose this voltage source is replaced by a current source. Okay, this voltage source is replaced by a current source. Supposing down. So can you write the KVL equation in this circuit? I'll explain you why not. Because to know a subject we have to know why we can't. Okay. So now listen. If we try to write the KVL equation in this equation, there is a current source. Okay. The current source means it is maintaining a current. This is suppose a current source of 5 amperes. This means, let it be I. So this means it is maintaining a 5 ampere current across this direction of the mesh. So now why we would go to write KVL equation? Suppose we are going to write a KVL equation. Okay, IR, the potential drop across this point. Okay, I can't see any other potential drop. I can't see any other single potential drops. But you tell me how this 5 ampere current is coming. So this current source is nothing but a hidden voltage source with a resistance. That's why the current is coming up here without a voltage. So how can it can be maintaining a 5 ampere current? So voltage current sources are nothing but hidden voltage sources only. Okay, so we can write IR here, but we don't know the potential voltage how to write. So it's very difficult. It's very difficult to write a KVL equation when a current source is present. So alternatively, how can I write an equation over here? It's simple. The simple way is in this single mesh, it is maintaining a current of 5 amperes. What I want to know, that is current. I want to know current. That's why I am writing this on KVL equations on all right. So I am wanting to know current. I know that it is here. This circuit 5 ampere current is there. I assume the direction of current to be like this I, and the current is also flowing like this 5 amperes. So simply I can say I equal to 5 amperes in this circuit. So this is a way of writing a equation for current when a current source is present. Now the things will get complicated only when there is more than one mesh. Now let's see. There will arise two cases. We will see one by one. Okay, we will see one by one. Case 1. Case 1. Minimum 2 mesh. Minimum 2 mesh for this. We already saw what is to be done for a single mesh. We will automatically tell this is the current. Now you can write the potential drop across the resistance I into R. The case 1 is of the current source is only present at one mesh. Either of one mesh. Okay, this is mesh 1, this is mesh 2. So the first case includes that the current source is either in the mesh 1 or in some this position in the mesh 2. Okay, if there is a current source in either of the mesh, then we can term it as case 1. Okay, so and what is the case 2? Case 2 is same current source if it is between the both meshes. If it is in between junction branch of both the meshes, then it is called as the case 2. So here this case 1 means it is only present in one mesh, and if it would have been in this junction point, in this between branch point, then it would have been in between two meshes, it would have been case 2. So we have different approaches to solve case 1 and case 2. So how to approach case 1? So we can write KVL, in mesh 1. It's hard to write KVL in mesh 1 because first assume the currents will be I1 and I2. So previously in the single mesh we discussed that it's very difficult to write the KVL equation over this point in the mesh 1 because there is a voltage source which is hidden. Because of that the current is maintaining and the current source is working. So I can't write the potential difference from here to here, so I can't write the mesh equation. Okay, leave. So what we again taught, we need equations. We need two equations so that we can solve this question. Okay. So we again learned from the last single mesh that if the current is, I am assuming to be I1 flowing here to here, and the questioner is telling me it is maintaining a current of 2 ampere because of current source. So simply I1 is flowing in this direction, I assume, and the current source is also providing a current of 2 ampere, I assume. So in this mesh, the I1 will be equal to 2 ampere only. If I would have assumed the opposite direction, then it would have been -2. That's it, nothing much. So when the current is maintained at 2 amperes, I assume my direction of the current of the mesh current to be I1 at the same direction. So I1 will be equal to 2 amperes. I got equation 1 simply. No need to write the KVL and all. Okay, because we know the current. We just want to know the current value only. Okay, now in mesh 2, we can use mesh 2. We can write the KVL from across this point going like this. Okay, so I2. Okay, 5I2 equation will be equation and mesh 2 will be KVL in mesh 2. Let's write KVL equation starting from here. Current is I2 to 5I2. Potential difference is -10 from up to bottom because we are hitting the minus sign first. So it's -10. Again coming into here. So I will assume this direction to be positive as of now because all the equations I am writing this direction to be positive. So this is I2 minus I1. If this is I2 going over here, this is I1. So I am assuming the current is flowing like this. So it had to be, I am assuming it had to be positive and greater. So I2 minus I1 into 1 over resistance, okay? Plus I2 minus I1 into 1 equal to 0. So 5I2 minus 10 plus I2 minus I1 equal to 0. So now we have equation I1 is equal to 2 amperes. Okay, so just put in the value of I1, 5I2 plus I2 minus 2 equal to 10. So 7I2 equal to 12. So I2 will be equal to 12 by 7 amperes. So now we both know what is I1 and what is I2. So we can solve any question. What is the potential drop across this 5 ohm resistance? It's I2 into R, which is 5. It will be equal into 5. It will be equal to 12 by 7 into 5. Okay. We can solve any question. What is the potential drop across this resistance? It will be I1 minus I2 into 1. Okay. Or I2 minus I1 into 1. It depends which is greater, which one will be greater. So you can easily say this I1 is greater, so that's why I write I1 minus I2 into 1. Okay, so like this we can solve case 1 of mesh analysis when a current source is present. So now look at the case 2. So we will be looking on to the case 2. The current source in between two meshes. We have a current source in between two meshes. Okay. So now in this case too, we have a current source in between two meshes. So it's very difficult to write any KVL equation in either of the mesh. In mesh 1 and in 2, the current is flowing, suppose I1 and I2. Now, if I am going to apply KVL at the mesh 1, I will start from this point and come across the loop, and the summation of potential drops will be 0. So how to know this potential drop? I don't know, because there is a current source, it's melting the current, 100% there is a potential drop. So I can't write the equation here. Let's go to mesh 2. I am starting from here, coming over here, and again I am unable to write the KVL equation because in between there is a current source and I don't know what is the potential difference or drop across this current source. So the only way to solve these problems is a fundamental called supermesh. We have to use a supermesh to solve case 2 problems when there is a current source in between two circuits, two meshes. Okay. So what is a supermesh? Okay. See, the KVL law stands for the potential drops around a point across a circuit is equal to 0. So I can choose any path and come back to the same point, still the potential drops across that path will be equal to 0. Okay. So suppose I am starting from here. So one path was this for making a loop, one path was this in this equation, and I am both unable to use the both. So one more path is there if you see closely. If I start from here and write like this, obviously current will change in both meshes, and I already assume different currents only, and I come like this and again come to this. There are no current source present over this condition. Okay, there in this path there are no current sources, so I can easily write the equation for a supermesh and it's still valid. Okay, so this is the supermesh. I start from this point, I just go on to the second mesh and again I come back to the same point. So the potential drops across this path will also be 0. So KVL and supermesh. What is the equation? Okay, coming from this side, from this point going to this, there is a potential drop of minus 10 volts, plus there is current flowing I2 across this direction. It will be I2 into 1 IR, again come to this point. There is 2 plus 2 I1, okay, I into resistance equal to 0. So upon solving, I2 plus 2 I1 will be equal to 10. So equation 1. But I only got one equation. I only got just one equation in this manner using supermesh. I only got equation 1. But in order to solve an equation which have two variables, I need at least two equations. So how can I write another equation? I always told you that the current source always maintaining a continued source flow of current which is equal to 2 amperes in this case at upward direction. So we also can say the 2 ampere current is flowing through this branch at an upward direction. So what is the current in this branch? I assumed I2 to be going up and I1 to be going down. I2 is going up, I2, and I1 is coming down as per my assumptions. So which will be also equal to 2 amperes since I2 is greater. So I2, since I2 is flowing upwards and the current source is also making the current flow upwards, so 100% I2 will be greater. So I2 minus I1 will be equal to 2 amperes. This is the second equation. So one equation I will get from this current source and one from this supermesh. Okay, because it is maintaining a 2 ampere current, I can easily say the difference of the current will be equal to 2 ampere. So no doubt about this. And how to use the sign convention, since the current source is already maintaining a current upwards, so whatever current I have assumed to be going up direction in this branch have to be greater. I have to assume. If it comes negative, then my assumption is wrong, but it will not come negative because it's already maintaining 2 amperes current upwards, so I2 have to be greater. Anyway, I2 have to be greater, yes. So anyway, so I have two equations. So what will be I2 from here equal to 2 plus I1. So substituting 2 plus I1 here, 2 plus I1. So it will be 3 I1, 2 plus 3 I1 equal to 10 volts. So I1 equal to 8 by 3 amperes. Okay. From this equation we saw I1 to be 8 by 3 amperes. Okay. Yes. And now how to calculate I2? I2 will be 2 plus 8 by 3 amperes, which will be equal to 14 by 3 amperes. Okay. So this is how we solve the case 2 when the case of a mesh analysis when a current source in between the two mesh positions. So we will have one equation in the super mesh form and one equation the difference of current which is maintained by the current source. Now look at let's go a little deeper in this subject. We saw a case where only one mesh was present. It was easy, you can directly say the mesh current is equal to the current source. Now we saw two cases of two meshes. One when the current source is present in one mesh and another when it is in middle of the junction. So there are two different approaches to solve this. And now let us look at same problem with three meshes, okay, or more, three or more meshes. And let's make it more complicated. So this is one case. Now suppose this is another case. Here only one current source is present at only one mesh. It could have been like this or it could have been like this, but only in one mesh, either in mesh 2 or mesh 3 or mesh 1, not in junction. And another case would be so here we can see three meshes are present. Mesh number 1, mesh number 2, mesh number 3. In this case, how to approach this problem? So we already know what is I1 is. Because some value will be given, we already know what is I1. I1 equal to sorted. So now we can write KVL at these two meshes. So we will have KVL equation 1, KVL equation 2. So here we got 3 equations and 3 variables, I1, I2 and I3. We will easily able to solve. So this was the easiest case of 3 mesh with a current source and only one mesh. Either it be here or it be here. If it would have been, suppose it would have been here, so nothing will change, just only one thing will change. Suppose this direction, I assume the I3 to be like this, I3. So nothing but the I3 will be known in this case, okay, and I have to write the equation for this and this loop, okay. So it's easy. Now the complicated part is, if suppose like this question is there, let's see how we will solve across this. Suppose the problem is that 3 mesh circuit is there and one current source is in between of 2 meshes, okay, it is in between of any 2 meshes. So the values are given 2 ohm, 3 ohm, 1 ohm. Let me it simple. This is 5 volts, this is 10 volts, this is 50, this is supposed to 20 volts. So the equation is here, the circuit is here. So let's suppose, so what we will use, since there is in between of 2 meshes, we will think of something we just learned, that is supermesh. Yes, we will learn. So we need 3 equations. How many equations I can make? 4 equations. One supermesh I can start from here. I can go to like this. I can write equation like this. I can follow this path. Still it's a closed path. Still if I start from here and come like this, it will be a closed path, and the KVL sum of all the voltage drops will be equal to 0 by KVL. So I can assume the currents to be Y1, I2 and I3 with the respective direction which I assumed. So the current source in the problem is given 5 amperes. Okay. So next thing what I can think of, another super mesh which is equal to this. This is also super mesh. Yes or no? This is also a super mesh. So I can start from here and write equation from here to like this. So I can get another equation. So first super mesh, second super mesh. I only need 3 equations to solve this problem because I have 3 variables. Already I got 2 equations and one more equation I can get from this particular current source. I know that I3 is going upward and I1 is going downward in this case, and the current source is maintaining upwards 5 ampere current. So I3 will be greater than I1 because the direction is of upwards already given in the question. So I3 minus I1 will be equal to 5 ampere. So this is the third equation. Even I can have one more equation. What equation? One more equation will be of this mesh. Okay. In this mesh, I can start from this point, go like this, and come over this. Okay. So that could have been one more equation. So I don't need 4 equations anyway. So 3 equations are more than enough to me. Okay. So what I will do, either I will write this one or this one or this one. Okay. Any 3 equations I can form. One super mesh. Okay. 2 super mesh. Okay. And 1 mesh. Okay. I can form 3 equations more. Already got 1 equation. I will form 2 equations more from super mesh itself. Let's start off this super mesh. So all the potential drops here. I1 is flowing. Okay. 3 I1. First super mesh I assume to be like this. Okay. Like this. Okay. This. Okay. Full one. So 3 I1. Here the current is I2 plus I2. Now going upward from this, I hit the positive first, plus 10. Now I hit the negative first. If I go in like this, so minus 20, coming. So again I1 is flowing, plus 2i1 plus 2i1 equal to 0. Let's simplify this. I2 3i1 and 2i1, so it will be 5i1 plus i2. So no use of i3 over here. Plus 10 minus 20 minus 10 equal to 0. So it will be equal to 5i1 plus i2 equal to 10. So equation. So I got equation 1 and equation 2. Now how to get equation 3? Either I write the equation for this or of this supermesh. Okay. So when we are using supermesh, let's write with supermesh itself. Although I can have one more equation from this mesh itself. So let's write this equation. Equation 3. Let's start from here. 3i1. Coming from this to that, I hit the minus first. Minus 5 volts. Now I have to go like this because I have to avoid this because there is a current source. So I am going like this. Again I hit the minus sign first. Minus 20. Coming like this. Right. Went like that. Okay. And now I am coming like this. Again I got 2i1. Okay. Plus 2i1 equal to 0. So here 5i1 minus 25 equal to 0. So from here I will get i1 equal to 5 amperes. Okay. So I got i1 equal to 5 amperes, and I know that if I put this in equation 1, okay, so this was the third equation which we formed using this supermesh, so if I put this into this, so I will get i3 equal to 10 amperes. Okay, I got i1, I got i3. Now i1 and i3. So in order to know i2 I will just put i1 in here. So 25 plus i2 equal to 10, i2 equal to 35 amperes. Okay. So just as what we have done is that I put the i1 value in this equation. So 25 plus i2 will be equal to 10, 25 i2 will be equal to 2 amperes. So I got all the currents. Okay, I got all the currents. Now suppose this equations became easy because of choice of the parameters. Even if the equations would have been long, then all three variables in each equations would have been present in some tough questions. If suppose I got equations in this, it was easy, so I can solve it manually. Even if I got three equations like, okay, suppose ax1, ai1, suppose, okay, ai1 plus bi2 plus ci3 equal to 10, suppose, and let it be xi1 second equation plus yi2 plus zi4 equal to 20, and suppose a third equation, this was easy equations, one variable was missing, and third equations, if I have been got like suppose anything, you can suppose di1 plus ei2 plus fi3 equal to 30. So if I would have been given this complex equations, suppose complex equations I have been I got in suppose the complex equations I would have been getting when solving this when writing this loop currents, all equations have all the unknowns. Okay, so these values are the coefficients we will know, like this here 3, 5, when we will put the values. So how to solve this? We will solve this type of equation either using calci. You can use calci. Okay, calci, option 1. Okay, option 2, if you want a video how to use calci and solve 3 variable equations, then I will teach you that also. Or second option will be using matrices. Okay, So how we will write the matrix? So this will be equal to A, B, C, X, Y, Z, D, E, F. Okay. I1, I2, I3 equal to 10, 20, 30. Okay. So how I can, so the magnitude of this matrix, okay, how to find the matrix magnitude? Plus minus plus A, okay, YF minus ZE minus B, negative sign minus B, leave this rows, XF minus ZD, ZD, XF minus ZD plus C, leave this rows, XE minus YD, XE minus YD. So this would have been known as delta. So magnitude of this matrix would have been delta, and we have to find delta 1, delta 2 and delta 3. So how to find delta 1, delta 2 and delta 3? If I, in this matrix, I replace this in this column, it will be delta 1. So this is delta 1. Okay, let it be X A X T. I am writing here. So delta 1 will be magnitude of 10, 20, 30. I replace this column with this equation, and it will be B, Y, E, C, Z, F. So you will get some magnitude. You can take out the magnitude like that. So delta 2 will be this equation replaced in this column, and delta 3 will be this equation replaced in this equation, and then magnitude. So by this you can find I1, I2 and I3. I1 will be equal to delta 1 by delta. I2 would have been equal to delta 2 by delta, and I3 would have been equal to delta 3 by delta. So if you get, here I got simple equations, I can easily solve. But if I get some complex equations, I will use Gregor's formula or this matrix form to find out the answers I1, I2 and I3. Or even I don't want to use this matrix formula, I can use a scientific calculator to calculate this. Hope you enjoyed this video, and do subscribe my channel and like this video, and you can suggest me what more topics you want to learn, and I will be making the video of the same, and or otherwise we will go regularly through one by one topics in electrical engineering. Thanks for watching.